Hey guys, hope everything is going well. We're going to take notes on multi-step equations today. So have your notebook out. My dog is also making noises, so that's cool. Like we always do, it's gonna be weird. Okay, like we always do, write the date at the top of your paper, and then we're gonna title our notes. And the title of our notes today is multi-step equations. We've been practicing this already. I just want to review it briefly just because some questions have come up about it, and I just want to make sure that we're getting some practice problems and some review on it. And I'm going to change this color because this color is awful. So let's go to like a darker blue. Okay, so lucky for us that on multi-step equations, really there's only a couple steps. Okay, so we're gonna just list the steps today. So the first step is to simplify each side first. So do everything you can on each side first. So combine like terms, anything like that. Distribute, anything that you can do. You're going to simplify each side of the equal sign first. The second step then is to get all your variables. So get all variables on one side, variables on one side. There we go. And all your constants. Remember from last video that constants are just numbers, right? So I'll put that in parentheses. So anything that doesn't have a variable is a constant. So all your constants on the other side. On the other side. So really those are like, it's a very, very simplified version, but there's really only two steps here. I just want to go over the types of solutions that you're going to get on these problems because there are three different types of solutions, and some of you have asked me about them already, and so I just want to review so you have it written down and you can access it, what the three types of solutions are and what they mean. Okay, so I'm going to go ahead and clear this. I'm going to scroll down a little bit since we don't need that heading anymore. And we're going to talk about the three different types of solutions. Okay, so big if here. So here's going to be one type of solution. If you get your answer and your answer says that a variable equals a number. So if you solve, right, you do all those steps and you get that your variable equals a number. For example, like x equals 4 or something like that, right? Any number, doesn't matter. Okay, what that means is that there's one solution. And that solution is whatever you solved for. So in this case, the solution is 4. If you solve, and you get a number equals a number, and it's true, right? So let's say I get 5 equals 5, right? So I notice I don't have a variable. My variable's gone. So if I get something that makes sense like this, does 5 equal 5? Yeah, right? What that means is that the answer is all real solutions. And so what that means is that I can plug any number I want into that original problem and it'll work no matter what. Okay, sometimes we say infinitely many solutions. So that's another way that people have, you've maybe heard it before. Or sometimes you can write out infinitely many solutions. So 3 different ways to write the same answer. But in this class, you'll see me write all real solutions. Okay. So that means any number works, right? Up here, only one number works, right? If my answer is 4 and I plug in 7, it won't work, okay? But here, if this is my answer, then any number I plug into my equation will work. And then the last one is if you get a number that is not equal to, so we have an equal sign with a line through it, a number. Like for example, if I get something like 3 equals 7. Does 3 equal 7? No, right? So there's a line through it. It does not equal 7. So if you get something that doesn't make sense like this, then that means that the answer is no real solution. No real solution. And so I just wanted to go over this because a lot of the time, most of the time, you're going to get this first option, right? You're going to solve and you're going to get a number. But every once in a while, one of these other two happens, and it's pretty frequent that we see people just kind of like freeze and they're like, I don't know what that means. I don't know what to do, right? So now we have this written down. We know if we get two numbers that are equal to each other, and it's a true statement, then it's all real solutions. And then if we get two numbers that equal each other, it's not a true statement, it's no real solution. So we're going to do 3 examples real quick. Let's get rid of this. And we're going to look at some multi-step equations. So our first example, notice that I said equation, right? We're looking at equations now. So instead of just simplifying, we're actually solving because equations have those equal signs. Up until now, we've kind of just been looking at expressions that don't have equal signs. So we were just simplifying, but now we're actually solving. Don't run out of room here. Okay, and then plus 6 at the end. All right, so here's our multi-step equation because it's going to take more than one step, right? So the first thing I need to do, the first thing I see here is that I have parentheses on both sides, so I need to distribute. Okay, so I'm on the next line. I'm just going to copy the 7 down. 2 times 4x is 8x, and then 2 times negative 1 is negative 2. 5 times 2x is 10x, and then 5 times negative 1 is negative 5, plus 6. So I'm just still on that first step where I'm trying to simplify the whole left side and then the whole right side. So in still continuing with that, I see that the 7 and the negative 2 are like terms, so I can combine those. So that gives me 8x plus 5 on the left. And on the right, I have a negative 5 and a positive 6, so that gets me 10x plus 1. So now I've simplified the whole left side as much as I can and the whole right side as much as I can. So now I'm moving on to get all the variables on the one side and all the constants onto the other. So I'm going to subtract my 8x and fully believe in your capability to solve these problems. 10x minus 8x is 2x, plus 1, minus 1, minus 1. 4 equals 2x. And then divide by 2, divide by 2. And I get 2 equals x. Oops, sorry, that wasn't a very good straight line. Okay, so then the question is, what does this mean, right? Because I get a variable, this means that there's one solution. And that solution is 2. Sorry, my dog is okay. You don't have to write this one solution part. You can just write x equals 2. And that's okay. Or you can write one solution. I'm okay. Okay, let's look at our next example. So again, we're going to look at solving. So I want to solve 3 times 2x minus 4 equals 2 times 3x minus 6. Again, I'm going to simplify the whole left side, the whole right side, so I'm going to distribute. So 6x minus 12 on the left and 6x minus 12 on the right. I'm going to subtract my 6x. These cancel, and I'm left with negative 12 equals negative 12. Since that is a true statement, right, negative 12 does equal negative 12, my answer here is all real solutions. And I do have to write that. I do have to write all real solutions. Just leaving it as negative 12 equals negative 12 is not good enough. Okay. Okay, last one, and then we'll move on in our notes. We're going to solve 2 times x minus 4 equals 4x minus 2x plus 4. So again, I'm going to distribute 2x minus 8 on the left side. On the right side, I have 4x. This negative distributes, so I get negative 2x minus 4. And I can combine like terms on the right-hand side, so we're going to go ahead and do that. 4x minus 2x is 2x. If I subtract my 2x to both sides, my 2x's cancel, and I get negative 8 equals negative 4. And that's not a true statement, right? Negative 8 does not equal negative 4, so here my answer is no real solution. So no number that I plug in, there's no number in existence that I can plug in for x that would make these two sides true. Yes, and that's what that means. And then same thing here, any number I plug in for x makes these two sides true. Okay, so moving on, we're going to look at what if an equation contains a fraction. Okay, so if an equation has a fraction. So now things can get a little bit more complicated, but we'll try to make it as less complicated as possible, okay? So what we're going to do, the step here, is that we multiply every term. My dogs are about to start barking. Multiply every term, and I'm going to even underline that, okay, by the least common denominator. I can almost see you guys rolling your eyes at me as I say that, right? The LCD, which is the least common denominator. So the reminder on that is the least common denominator is the smallest number that all of the denominators of the fraction go into. Okay, so don't panic too much. I think when we do an example, we'll be like, oh, okay, no problem. Miss G's the best teacher ever. Thank you so much for teaching me this. And I'll be like, you're welcome. Okay. So here I want to solve x over 2 minus 7 over 9 equals x over 6 plus 2/3. So lots of fractions going on, right? So the thing that we're looking for is what is the least common denominator. So the LCD. So I'm going to look at my denominators. I have 2, 9, 6, and 3. And I'm going to show you the fastest way to find the LCD. You take the largest number in the denominator, which in this case is 9, and you look at multiples of 9. So I'm going to say, okay, 9 is the first multiple of 9, right? Does 2 go into 9? No. So automatically 9 is out. The next multiple of 9 is 18. Does 2 go into 18? Yes. Does 9 go into 18? Yes. Does 6 go into 18? Yes. And does 3 go into 18? Also yes. So because all of them go into 18, that is my least common denominator. And I'm going to show you what happens. So now what we do, let's go with a red, is we are going to multiply every single term by 18. Notice I'm writing the 18 on the left-hand side of the parentheses. That is because I do not want you to think that it is an exponent. We're not raising it to the 18th power. I'm multiplying it by 18. And then something very special happens. This is going to be a lot of back and forth for colors for me, but that's okay. I have 18 on top and 2 on bottom. So if I divide those, right, 18 divided by 2 is 9. Give it a chance to get the same color back again. So then I get 9x, right? The 9 is there and the x. Same thing here, I have 18 divided by 9, 18 on top, 9 on the bottom. 18 divided by 9 is 2. So when I go back, now I have 2 times 7, which is 14, and it's negative. So negative 14, almost the same color. Right? It's okay. And then I'm going to just keep going. Here I have 18 divided by 6, which is 3. So 3 times x is 3x. We're getting all the shades of blue going on today. And then the last one, 18 divided by 3 is 6. And 6 times 2 is 12. Okay, and now I have an equation that is easily solvable and it no longer has fractions. So I'm going to subtract the 3x. These dogs. So it gives me 6x minus 14 equals 12. I'm going to add 14. Add 14. And I get 6x equals 26. And so I get x is equal to 26 over 6. But that reduces. So 26 over 6. We can divide both of those by 2. So I get 13 over 3. So there's one solution here. And the solution is 13 over 3. Okay, moving on to the next example. We're going to do a couple more of those with the fractions. We're going to do one that's a little bit more difficult. Okay, so this example I want to solve. And I'm going to write 2x minus 7 all over 3 minus 5x plus 4 all over 5. And this equals negative x minus 4 over 30. Okay, and I have to find my LCD. So my biggest number here is 30. So the first multiple of 30 is 30. So does 3 go into 30? Yes. Does 5 go into 30? Yes. So my LCD is 30. So that means that I'm going to multiply every single term by 30. Okay, so 30 on top, 3 on bottom, so 30 divided by 3 is 10. So that's going to get me 10 parentheses, and then I still have this 2x minus 7. So that doesn't just get to like go away, right? It's still there. Here I have 30 divided by 5, which is 6. So I have minus 6 times that 5x plus 4 equals, and then lastly, 30 divided by 30 is just 1. So I don't need to write the 1. So that's kind of nice. So that just gives me negative x minus 4. And now again, this is something that we know how to solve. This shouldn't take us too long, right? We distribute our 10. So 20x minus 70. Then we distribute our negative 6, so negative 30x minus 24 equals negative x minus 4. Simplify the left side, combine our like terms. So 20x and negative 30x is negative 10x. And then negative 70 and negative 24 is negative 94. And this equals negative x minus 4. Multiple ways to do this here. I'm going to add 10x now, just because I want my x to be positive. Negative 94 is equal to 9x minus 4. And then last step, I can add 4. Add 4. Negative 94 plus 4 is negative 90 equals 9x. Divide by 9. Divide by 9. X equals negative 10. Woohoo! So again, one solution, and the solution is negative 10. Okay, so our last example is going to be one that I want you to try on your own first. Okay, so you're going to write down the example in your notes, and then you're going to hit pause on this video, and you're going to try it and use the examples above to see if you can solve it on your own. And if you mess up, that's great. Awesome. I love it. Okay, but at least you're trying. So I do really want you to pause the video and try it, because if you don't try it, then you're not going to learn it. So 3x minus 2 over 12. I'm going to write this neater. That was not very pretty. I can do better. 3x minus 2 over 12 minus x over 9 equals x over 2. So first thing is you have to find the LCD, and then go from there. So go ahead and hit pause on the video, and I'll see you when you're ready to go over it. Okay, so hopefully you guys gave this a shot. Let's start with going over and finding our LCD. So the biggest number here is 12. So I'm going to ask myself, does 9 go into 12? And the answer is no. So 12 doesn't work. The next number is 24, right? The next multiple of 12 is 24. Does 9 go into 24? No. So we keep going, right? The next multiple of 12 is 36. Does 9 go into 36? Yes. Does 2 go into 36? Yes. So my LCD here is 36, which means I'm multiplying every single term by 36. It's hard to write that small, but those are 36s, okay? So then I'm just going to go through 36 over 12. So 36 divided by 12, the 12 cancels, and this becomes a 3, right? 36 divided by 12 is 3. So that gets me 3 times, and then my 3x minus 2. Okay. And then 36 divided by 9 is 4, so the 9 cancels, and the 36 becomes a 4. So I get minus 4 times x equals, and then 36 divided by 2 is 18. So this becomes an 18. So it equals 18x. And again, this is something that I know how to solve now, right? So 3 times 3x is 9x. 3 times negative 2 is negative 6. Minus 4x equals 18x. I'm going to combine my like terms. 9x minus 4x is 5x minus 6 equals 18x. Now I'm going to get all my x's onto one side. So I'm going to subtract my 5x to the other side. Negative 6 equals 18 minus 5 is 13, so 13x. I'm trying to get that x by itself, so I'm going to divide by 13, divide by 13. So I get x is equal to negative 6 over 13. And that fraction does not reduce because 13 is prime. And that's it. So hopefully you guys got that. That'd be super cool. If not, just make sure that you fix it in your notes so that when you go back to look at this problem, you're not looking at incorrect work. If you guys have any questions on this, please make sure that you reach out to me, like I said before, right away. Okay, like as soon as you need help, let me know, and then we can go over this. And otherwise, you do have practice that you're going to do on this, so you'll get much more opportunities to give it a shot. So other than that, that's it. Hope you guys have a great day, and I'll see you later.